Hello, my name is Brendan Enrick, and I'd like to welcome you to DevChatter Basics. In this episode, we're discussing types in C#. Understanding types and how a high-level object-oriented language like C# is using them can help you work better with your code. Whether you've been using the language for years or you're just starting out with it, a good foundation of the basics can help you improve your code. Get comfortable as we learn about types. Before we get too far ahead of ourselves, I want to make sure that everyone is up to speed by explaining what types are. In simple terms, the data that we work with in a program has a type. The type of the data defines its structure. If it's a simpler type, like a number, it would define whether it's a whole number, how large the number could get, whether it supports negatives. Some numbers are stored in a structure that's similar to scientific notation. We call those floating point numbers, and they're the common way of working with non-integral numbers, as in non-whole numbers. Some types are more complex, though, and are composed of multiple other pieces of data, and the most complex data types define behavior in addition to their data. Let's start by establishing a foundation for our understanding of types in C#. As a typed language, everything we work with in C# has a type, and there are two categories of types in C#. There are value types, and then there are reference types. Let's go ahead and dig into these a little bit further. When you create instances of a value type in C#, it is kept on the stack. In simple terms, that means that it's stored in memory with the method it's created for. That means we don't have to allocate additional space for it somewhere else. If you are to pass that value type variable to another method as an argument, C# will create a new instance of the value type to be included with the next method. That would leave you with two variables having the same value and are instances of the same type. If you change the value of any one of those variables, only that instance changes. The others will remain the same. By contrast, when you create instances of a reference type, C# keeps only a reference to the data in the method, and will put the actual data of the object into the heap. Just think of this as elsewhere in the program's memory, because we're only referencing the data. If we call another method and give a reference type object as an argument, we're actually only passing a copy of the reference itself, not a full copy of the data. Both references will point to the same place in the heap. This means that both variables will be accessing the same object. If you've ever heard the term managed memory in reference to C#, this is the reason why it's called that. In fact, C# is managing this memory allocation and the collection of that memory when it's done. Speaking of collection, when you leave a scope in your program, all of the variables that existed within that scope, the value types will get cleaned up, but the reference types, the reference will go away, and the memory will need to get cleaned up later. And all that will happen is you will lose a reference to that memory. When this happens, that object is out there and waiting for what's called the garbage collector to clean it up. Let's talk about some example types for value types. The most common value types that you'll use in C# are the numbers. The integers, the longs, the floats, the doubles, the Boolean values, these are all numbers inside of C#, and they're all value types. Closely related to the numbers are the enums. They're also value types, and this should make sense because enums can be cast to number types easily within the C# language. If you were to create a more complex value type, you would do so by creating a struct in C#, as struct objects are value types. The most common objects that C# developers create are reference types. And this is because we create a lot of classes, and classes in C# are reference types. This isn't just our classes either. This is all the built-in classes that exist within the .NET and .NET Core frameworks. Additionally, the collection types, even if the collection is of a value type object, are all reference types, because the heap is where objects of changing size work best. Though how that changing in size actually happens is a lesson for another day. Having those collections be on the heap means that all of our generic collections, our types, our strings of characters, and all of the arrays are all reference types. Finally, both interfaces and delegates within the C# language are also reference types. Keep in mind that these last two are a slightly more advanced concept. We'll be making future videos on DevChatter Basics to explain both interfaces and delegates. Be sure to check out those to learn more about the interfaces and delegates that are part of reference types. One of the more advanced concepts in a typed language is the concept of polymorphism. Don't let that word scare you off. It's less complex than it sounds. It really just means that an object can be used as any of its forms. Think of the poly in this word as many and the morphism part as changing forms. So many changing forms of an object is all polymorphism means. In C#, this concept works by an object being able to have more than one type. Type is more like an attribute of an object in C#. The most specific type is the one it's created as, but it can be used as other types as well. For example, an object of any type defined by a class in C# can be treated as the system.object type, since it's the base type in C#. And we won't get into the distinction of the difference between object and system.object in this course. If you understand how inheritance works in C# and how one class can inherit from another, this is a form of code reuse, and it allows for a child object to share some of the structure, either the state or the behavior, of a parent type. It gives you the same state and behavior that the parent had in the child. When we do this, we can actually treat all instances of the child as if they were the parent. Notice how in this image that we've got here, even though that object doesn't quite perfectly fit, it's close enough and clearly did fit, so we can treat it as such. This concept is called polymorphism, and it allows us to do a lot of really useful things in programming that are outside of the scope of this video. In other episodes, we'll dive into patterns that use polymorphism to leverage some really useful results in our programming. When we see those, you'll see how polymorphism can really shine and help you in your code. Thanks for learning about types with us. We'll be making more of these episodes, and we hope to see you on our live streams on Twitch at twitch.tv/devchatter. You can find links below, and be sure to hit the like button and subscribe to catch all of our DevChatter Basics episodes. Happy coding, everyone!